Today we're going to be talking about sections 1.1 and 1.2, lines, functions, and graphs. And there are three different forms of equations of lines that I want you guys to be familiar with. Slope-intercept form, y equals mx plus b. Hopefully you remember that. And a lot of the stuff in this lesson you're going to remember. Now, point-slope form is a form that some teachers use and some teachers don't. I really like this form, especially in AP Calculus, because you don't have to simplify. All you need is a point that's on the line, and we're going to call that point x1, y1, and we need the slope, which we're going to call m, and our form is y minus the actual value of the point, y1, is equal to m times x minus x1, where again y1 and x1 are the actual points that are on the line and m is the slope. General form you don't use a lot of. I have some old multiple choice tests, and sometimes the equations of the lines are in general form, so I'm going to give that to you guys just in case, but a lot of times you don't really need this. Ax plus by equals c, where a, b, and c are all integers, and really weird thing that came up the past few years in the math department, a has to be positive. So they're all integers and a has to be positive. Okay, writing equations of lines. Now I know you should be able to do this. We're going to be writing so many equations of lines. That's a skill that I really wanted to make sure you guys know. And we're going to be talking about parallel lines and perpendicular lines. Okay, so first you have to put this equation in y equals mx plus b so that you can get the slope. So solving that, so now our parallel line has the same slope. I'm going to use point slope form. So y minus y1 is equal to m times x minus x1, where this is x sub 1 and this is y sub 1, since those are the points that you're going through. So we have y minus something is equal to x minus something. For parallel lines, your slope is the same as your normal line. So 4/3 goes in there, and then as I was talking about, x1 goes here, so that becomes a plus 12. y1 is a positive 3. You're welcome to use slope-intercept form, but if you use point-slope form, you could just leave it like that. Now our perpendicular line, not lime, y minus y1 is equal to m times x minus x sub 1. And again, it's now just a matter of plugging in. Y minus goes to that same point. 3 is equal to m, we'll get to that in a minute, x plus 12, since we're passing through the point P. Now your slope is the opposite reciprocal. So that would be negative 3/4. Domain restrictions. Really, there's two functions that have domain restrictions that we often talk about. Rational functions. So we have some rational function where we have some polynomial on the top and some polynomial on the bottom. Your domain restrictions happen when the bottom function can't be equal to 0. So when that function equals 0 is your domain restriction. Rational functions. So a rational function happens when you have f of x underneath some radical. And it all depends on if n is even or if n is odd. If n is odd, f of x can exist in the real number solutions. Okay, so I can have any real number in there for my function because I can cube root an even number, I can cube root an odd number. Or I'm sorry, a cube root a positive number or a negative number. But if the root that you're taking is even, then that function must be greater than 0. In this example, we need to look at this function here, this equation, and identify the domain and range, graph the function on our calculator. So first I want us to look at what this function is. It's a square root function, but there's an x squared inside. So if I were to square both sides, I just want to show you what this should look like. Add the x squared over to the other side. What you all should recognize this is this is a circle with the center at 0, 0, with a radius of 4. But it's really not a circle, because if you look at this, let me erase what we have here, we just have the square roots. Remember that when we're looking at the square root of a function, all of my outputs have to be positive. So it's really a half of a circle. Okay, so it's a half of a circle with your radius, with your center at 0, 0, and the radius of 4. This is a really important function. And I realize this is the first video, but this is going to come back later on a few times throughout the year. So let's look at what our graph looks like. Okay, because of what our calculator does and where I stole this from on our calculator, 0, 0 is where our center is. It doesn't look extremely circular. But notice how I have a radius of 4, because this is rectangular and not square. It kind of looks like an oval, but it's actually a circle that comes down there and there. So let's look at what our domain is, and let's look at what our range is. So our domain for this one, what are the x values that I can get out that are going to give me a y? Well, that is from -4 to 4, because when I plug in all these numbers, I can get an output for a y. These are all the x's that I have on my graph. The range, the smallest y is 0, and the largest y is 4. Okay, even and odd functions. Please make sure you write this down. This is the definition that I want us to be using. An even function, f of -x is equal to f of x, and one of the properties is you're symmetric about the y-axis. An odd function, f of -x is equal to f of x, and we're symmetric about the origin. Those are the key things that I want you guys to know from this. Determine whether you're even, odd, or neither, and I want you to use the definition. So first find f of -x and see if you get back the original problem. Remember, y is a fancy way of saying f of x. So I plug in -x, and I want you to show me plugging in the -x, because we're getting used to doing this for much more complicated things later on in calculus. So here we have -x cubed plus x. Now let's figure out what negative f of x is. Okay, I knew I wasn't even because I didn't get back the original function. But if this f of -x equals negative f of x, then our function is going to be odd. So then what I do is I simplify, I distribute that negative through, and I've distributed correctly. So since f of -x is equal to negative f of x, the function is odd. And I would want you guys to write that. The function is odd with this definition piece. Graphing piecewise functions. This is going to be really, really important. Okay. Graphing piecewise function, I'm graphing the line y equals 2x minus 1 for x is less than or equal to 0. So, -1, but I have a positive slope, so I go negative and negative, negative and negative. Part of our graph looks like that. That's this top part. Next part is a x squared plus 3, so it's going to look like a parabola for x is greater than 0. So I plug in 0 for my x to get where my graph starts. We start at 3. And then I plug in 1, and I get 4. I plug in 2, and I get 7. Graph looks like that, with an open hole at the y-coordinate of positive 3. Now the last thing that's really important for us in calculus is composition of functions. So we have our f of x function, and we have the g of x function. And I'm finding g of f of x. So I'm finding g of the function 2x plus 3. So my g of x function then is something squared minus 5 times that something, and we have 2x plus 3, 2x plus 3. Now going through and simplifying, I'm going to go through this very fast because this is all basic algebra that you guys should know. And we simplify to 4x squared minus 2x, plus 2x minus 6. Okay, that is it for today. Right below this video, you should see a Google form. Please make sure that Google form is submitted on time.